Hello. A discussion we had on means friction 2, where we find the volumes of prisms. This is a continuation of that discussion, where finding the volume of a prism, we deal with that of a cuboid, a cube, and a cylinder. So we are having a question on that regard. A cylindrical metal is of length L centimeter, external radius of R centimeter, and internal radius of R, which is the capital and the small letter centimeters. So we have to find the volume of the metal. So let's create some mental picture by drawing a diagram. Let's see if we have our cylinder. Let's say we have it this way. Good. You know, in this cylinder, we are going to have this place to be the height. So let's label it H. Now, if we take this is going to be a hollow cylinder. But in the case that it is going to be a metal, it is going to have some thickness. There will be some thickness assigned to this. So let's see the depth, or how thick is the cylinder. If we take a pipe, you will see that there will be some thickness. Let's just say, good. So with this, we know this is how thick the cylinder is. Don't forget to find the volume of a prism. We mentioned that the volume of a prism is the area of the cross section. The area of the cross section times the height. So the height is going to be used, then the area of the cross section. If we cut the cylinder into pieces, on the view, what will you see? In this case, you'll be seeing a circle. So the area of the circle times the height will give us the volume of the cylinder. But here we are seeing a thickness. So if we take the inner circle, you'll be seeing the center over here. So movement from the center to the circumference is what we refer to as what? The radius, small letter r, which is what? The internal radius. The internal radius. So this is our r centimeter. Then if this is still the center, then movement from here all the way to the circumference of the bigger circle will also give us the radius r, center to the circumference. So what are you finding? You want to find the area of the cross section, right? And what is the area of the cross section? This is going to be an empty space. So this is what is the material of the metal being used. The metal are not in the middle. That is the hole. So the material of the metal is found at this shaded portion, right? So if I'm looking for the area or the material in the shaded portion, I need to know the total area of the bigger circle minus the area of the smaller circle, right? If I take away the hollow space away from the bigger circle, I should be finding the thickness. So we know that volume of metal is going to be area of the cross section times that of what? The height. So how do we get the cross section? We first of all find the area of the bigger circle. And the area of the bigger circle is going to be pi r what? Squared, right? But the bigger circle is having a radius of capital. You can see that's what? The capital R. So we are going to say pi r squared. Pi r squared, right? Then we need to find the area of the smaller one and subtract. So minus pi r squared multiplying the height. You can see. So this is going to be the area of the cross section, the thickness of metal being employed or being used, times the height. So this becomes the volume. If you want to find the volume of any cylinder that is having a thickness, the cross section is going to be the area of the bigger circle minus the smaller one. But we can see that there is a common factor of pi, which we can factorize. So if I factorize the pi out, I'll be left with r squared, which is capital, minus the r squared, which is small letter, which will still multiply the h. So now we are having three factors. Pi is multiplying the bracket, multiplying the r. So we can now bring the pi out to make it pi h times r squared minus small r squared. So this will be the simplified version of the formula that can be used to find the volume of metal of this cylinder. I guess you follow it. This could also be multiplying it, this beginning. It doesn't change the formula. Then we have pi h. It's still the same since multiplication is what? Commutative. Thanks you for watching. Share, like, and comment. Bye-bye.